IP address. I will try maximum as short as
So,
that one, but it is a topic. Yeah, tell me.
so only this week we are having this networking class, sir.
Don't worry about this week or next week, but study daily.
Okay, sir.
Okay, study daily. So don't worry about all this. If you have any doubt, you can. We will discuss once your training is completed. Okay.
Okay, sir.
So
Thank you, sir.
Charan sir will be in touch with you. Okay. So don't, it's not a big deal. Okay.
Yes, sir.
So that's I told like what are the topic we pick up. So as maximum as you study repeatedly and also study widely. So try to know different type of issues, how to solve it. Okay. So there is a way of steps also there. Okay. And I didn't remember exactly like yeah, here it is. I told about this one or not. Yeah, this is okay. Guys, I am for me. You should get a information. You know, some people. Okay, why my internet is slow or what? Okay. For example, some people may understand by just hearing something. Like I show a blank screen and I explain. Just before I explain about a network troubleshooting without showing anything on a screen, right? So some may will be recollect old things. Okay. Even I showed something when I given as notes also, people may not get into the mind. Okay. So whatsoever it is, guys. So this is power set animated videos. So very recently, so even I have seen one or two times just what it is. I don't prefer to go to this kind of material because it's animated. Okay, it is animated and a single shot explanation only. It's not like my class like a repeated explanations. It is a single shot explanation. It is a animated because this is very useful if you are want to understand you like a easy to understand type, not easy to remember. Okay, it is like a story, like it is a animated story only, just for a kids where there is a lot of animated stories. Okay, like a rabbit tortoise kind of stories. Okay, they will tell in a story wise, easy to understand, easy to like you don't think it is something negatively like I don't understand, I'm getting confused. That kind of stuff won't be there. It is very easy to understand. Problem is it's not easy to remember because it's like a story. You hear, you understand, or maybe you like it. You understand or not, but you like it and you will forget. But why I'm telling this one, why I'm giving this particular channel it is. Okay, you can. So where is your batch? If anyone, or maybe you have a time, so now you have a time, a particular thing like you may not, you want to know about a modem, or maybe you want to know about a Wi-Fi device, or maybe a switch, maybe an IP address, maybe LAN WAN explanations, maybe a cloud computing, maybe about a MAC address. So it is a not 1 hour video. It is a 8 minutes, 5 minutes. It is 7 minutes, 8 minutes. For LAN WAN, I have taken 1 hour class, right? So subnet mask, Bluetooth versus Wi-Fi. So this is a hardware related. CompSHA A plus means hardware related. It is directly 3 hours video. Okay. This is network related. This is a network animated. See modem versus router. It is very useful part. I'm sharing only one video. Okay, so I'm sharing the channel. Okay, and also I'm sharing. This is not coming. Yeah, it is came like a modem and router. What is modem will do? What is router will do? What is Wi-Fi over router? What is wireless access point? What is hub and switch? See, it is a lot of devices, cables, tools, DNS, DDNS, DHCP, NAT, DHCP, NAT, like this. Okay, so there is some explanation. There is kind of stuff, including hardware related, CompTIA certification, network information technology, and some other videos also there, like storage devices, hard disk, SSDs differences. So just you have to find it out. Okay, it's only displaying limited. So what is proxy? What is VPN? What is VPN? What is RAID? FTP, SFTP? Yeah, this LAN WAN kind of stuff. Okay, SSD, BIOS, CMOS. Okay, ARP, address resolution protocol. This is SMTP POP3. Printers, DHCP. Okay, like this. So DNS, ping and trace route. So it is very easy to understand, but there are very small videos. Okay, better to go once. What are the doubt you have, so you can go through once. And while you once just watch once, because it's less than 10 minutes, just watch once, maximum 10 minutes, right? So watch once and watch it again. Second time watching, note down what point you got it. Okay, so that's why I told this is just by watching you understand, or you may got the point what it is. But point is you may not remember, or you not may explain it again how it is happened. Okay, that's why I'm trying to explain things without showing more in the screen, without showing more on the screen. So if I show more on the screen, then you will may understand. You may get something is okay, big thing is there, but you will forget. So put it in more words, more sentences. Okay, easy sentences, easy way of sentences. So whether you heard or read, or you understand something, you tried something, put it in a words only. Okay, guys. So this is I thought it is more helpful because even I already told our Sais are also shared some videos from there to here to the students. That's why I got interested. Okay, whether it really works or not. I don't learn from there. Okay, my learning is to by doing only. That's a different one. Okay, so anyway, I already started recording. Record is going on. Okay, so first of all, I will start with what is this kind of stuff, guys. We learn about OSA layers. OSA layer is a reference model only, and there is a lot of different network models are there. Okay, but out of all models, we are using TCP IP model only. Okay, so TCP IP model and see only. So what are we are using? That's what I'm trying to say. Okay. Okay, out of all models, we are using TCP IP protocol suite only we are using. Okay, so the protocol suite contain application layer, transport layer, internet layer, network access layer. This model came from the DoD model, like a Department of Defense kind of model it is. Okay, it's like a military based model. It's used for so many years. Then it is published as a TCP IP for all over the globally we are using TCP IP models only. We are all using star topologies only. Okay, we don't use the ring topology, mesh topology kind of stuff. Mesh topology used in a certain places only, not every places. Okay, because of star topology, easy to implement, easy to troubleshoot. It's not reliable, but still it is very easy to troubleshoot and it is scalable. So we use star topologies only. Different type of addressing is there, but we are all using IP addresses only. And IP addresses, we have IPv4 and IPv6 only. Okay, IPv4 and IPv6 we are using. Last one class, one girl asked me that's like, sir, what about a IPv5? Okay, yeah, it may be there. So in the while there are researching about IP addresses, implementing and testing about IP addresses, there is a IPv5 may be there. Okay, maybe there are concluded that is not more useful for next years. Okay, next few years. So it is better to go with IPv6. You will get a much longer period of time. Like IPv4 is still working. It's going to be vanish in few years. Still no longer maybe not useful because limited number of IP addresses in IPv4. IPv6 is getting a lot of billions of IP addresses we are getting. Billions of IP addresses we are getting. So that is why it is. Okay. So here it is. So that's these points always keep in remember. Okay. In a textbooks, internet, there are a lot of stuff is there, but what protocol suit, TCP/IP protocol suit. Okay. Star topology, IP addresses, IPv4, IPv6 we are using. But what is this IP addresses? IP address is a logical address. Already we discussed about IP address and MAC addresses, but just I am telling, IP address is a logical address. MAC address is a physical address. Physical means it's physical existing device. Okay, it's physical. How to tell? MAC address is on the NIC, network interface card. What are the NIC are using? Ethernet or fast Ethernet or Wi-Fi type of Ethernet you are using. Okay, so on NIC, the manufacturer of that NIC put a MAC address in it. Okay, so that's it is physical address. It cannot be changed on physical device. On direct physical device, MAC address is there. Physical address cannot be changeable. Okay, so IP address is a logical address. Okay, we are assigned an IP address based on our existing network. Based on our existing network IDs. It can be changeable and we are assigned an IP address based on the existing network. Okay. Next, what is this IP address? IP address is a logical address. IP address is uniquely identify a device in the network. Guys, when you are telling about uniquely identify a device in the network, tell like that only or practice. Otherwise, forget about it. No problem. Okay. Tell about what is the use of IP address. That's it. Okay. But if you say IP address, IP address, unique, it's a unique address. If you tell like that, it is wrong because unique address is MAC address again. IP address is logical address and IP address is uniquely identify a device in the network. Uniquely identify a device in network, that is completely. Okay, in a completely the sentence in the network you can see the bottom there is a 4 PCs in the network. Each PC having an identification for each PC to identify to communicate each other. So there is an identification, right? Uniquely identify a device in the network. We use network. Okay, so it's not unique address. Unique address is a MAC address. So do not say IP address is a unique address. That's very dangerous. IP address can change according to the network. So here it is. I use a 10 network, 10.0.0. network. I am using here. So okay, this present network it is. Okay. For example, same PCs I connected into different logical address schema, logical addressing part. Like maybe there it is 11.0.0. something I'm using. So based on that, I will have to change the IP address. Okay. Very simple. What is an IP address? It is a logical address. It's uniquely identified device in the network. IP address can be changeable according to the network. In IP addresses, we have a IPv4, IPv6. Two type of IP address, two versions of IP addresses are there. IPv4 is a in a binary 32-bit. IPv6 is a 128-bit. So IP addresses are mainly used for a only communication purpose. So don't worry about that. So don't that is just not justification part. Okay. It can be changeable. There is a public and private IP addresses also there. Whereas a MAC address, when you got a discussion, IP address and MAC address differences, MAC address is a physical address, cannot be changeable. We cannot change the MAC address, but about a MAC address already I given. MAC address cannot be changeable, but there is a MAC spoofing is there, MAC bindings are there. So that's a different situation, but in generally on NIC, you cannot remove that MAC address and you cannot put a new MAC addresses there. MAC address is a physical address, hardware address given by manufacturer of that NIC. Okay, it cannot be changed based on your network where you are connected. Based on that, it cannot be changed also. It's a fixed address. There is no public private kind of stuff. MAC address still it is valid within the local network only. You cannot directly communicate to any device using MAC address. Okay, MAC address is more like a unique address. It is just like this is the device. MAC address is, we don't have a naming schemes. That's we can identify a devices. For example, you have a 4 devices are there. Each PC having a NIC means each PC having a MAC address. Each PC having a MAC address. But whatever the IP address type you are using, the MAC address is same only. So it is very useful for to identify the device, not in the network. So I just identify a device. It is mainly like we can exact what this is the device. That's it. Okay, fixed name. It is a MAC address is 48-bit represented in 12 hexadecimal. We are all communicate with a IP address. Okay, so I want to send a packet to PCB. PCB IP address. Okay, from PC1 to PC2. I want to send a packet. I want to send a message. I want to send a request. What I have to use it? PC2 IP address only 10.0.0.12 only. For example, I want to ping from PC1. So ping 10.0.0.12 or ping 10.0.0.13 for PC3. Okay, so that is IP address I am using. I cannot ping to PC2 MAC address like a ping PC2's MAC address. It won't work. Okay, so devices don't understand each other in a communication. Okay, so because of we have to communicate with the layer 3 protocols only, not a layer 2 protocol. Okay, all communications by IP addresses only, not with a name, not with a MAC address. Of course, there is a role of MAC address is also there. Role of MAC address is there, but mainly communication with the IP addresses only. Okay, so MAC addresses are used to identify device and security. Like while you are transmitting a packet, so we are also using source MAC address, destination MAC address part also there. Okay, so this is what is an IP address and what is a difference between IP address and MAC address. Now I will tell few points are important, guys. What is the difference between IPv4 and IPv6? Okay, so IPv4 is a 32-bit. Of course, when you say bit, means it is a binary. Okay, zeros and ones manner only we are telling. Okay, so 32-bit. So 2 to the power of 32, 4.3 billion IP addresses. 4.3 billion IP addresses approximately, not more, right? Because it's a, if you put a 2 to the power of 32, you'll get a almost like a, if you want in a course, I will tell this is lakhs. So 429 crores, 429 crores, 49 lakhs, 67,296. That is the total one. Okay, so 4.3 billion approximately. IPv4 represented in a decimal format. So we will write in a regular numbering system only. So decimal format. Example of IPv4 is 192.168.1.110. Okay, so this IPv4 is 32-bit. This 32-bit is divided into 4 parts. IPv4 is divided into 4 parts. So 32 by 4 is 8-bit. Okay, so like this, 8-bit dot 8-bit dot 8-bit dot 8-bit. So this 8-bit we call it as a octet. Okay, this 8-bit we call it as a octet. So it's a 8-bit means 2 to the power of 8 is a 256. Okay, guys, in here we always count like this, 1 to anything, right? 1 to 10, 1 to 20, 1 to 40 kind of stuff. But here it is, we have to count from 0 to 9 type counting. 0 to 9 is 10. 0 to 5 means 6. 0 to 20 means 21. Okay, 1 to 20 is 20. Right? 1 to 20 numbers are 20 numbers. 0 to 20 is 21 numbers. Like that, 0 to 255 is 256 numbers. Means each octet, the size is 0 to 255. Each octet size is 0 to 255. Already I told this 32-bit is divided into 4 parts. 4 parts. Each part is a 8-bit. The 8-bit we call it as an octet, and it is separated by a dot. It's not point, it is a dot. So the first part of this 4 parts is first octet, second one is second octet, third one is third octet, fourth one is fourth octet. Next, this some people, for example, we have another trainer, so he will tell in a different manner. That is also good. Why? Because it is quickly understand, like a, you can easily use the IP addresses in this manner, like a WXYZ manner. In some textbooks, some videos, people use this pattern like a WXYZ. Okay, the W represent first octet, X represent second octet, Y represent third octet, Z represent last one fourth octet. Okay, so for your convenience, you can use WXYZ also instead of first octet, second octet, third octet, fourth octet words. Okay, but whatever it is, guys, 0 to 255, 0 to 255 is a one octet size. Means each octet maximum size is 0 to 255 only, not more than that one. For example, you got some IP address. Okay, even I have seen one English series. Now there are stopped that one, but English series is there. I've seen one English series is that in that one. So that's like there are more perfect than Indians, right? So they think the hacker lady is asking. Hacker means she's a forensic network related work. So she's there we thought like that is there are more perfect. So she asked like what is the IP address of that computer to see their files inside. So okay, so he will tell something like 400.300.200 something kind of stuff. I got it out. If it is a IPv4 address, why you got a 400? Okay, so it's completely out of range. It's completely out of range because it's America, sir. You don't know America. They use very big thing. Maybe there is a possible because it is America. Okay, impossible. Okay, so here it is, guys. The first IP address is 0.0.0. The last IP address is 255.255.255. Okay, so from 0.0.0.0 to 255.255.255, this total range is 4.3 billion IP addresses we are getting. Just like a numbering system, it will start like 0.0.0.0, 0.0.0.1, 2, 3, 4, 5, up to 254 and 255, and the next is automatically changed to 0.0.1.0. Okay, not 256. So 1.0, 1.1, 1.2, 1.3, 1.4, 1.255, 2.0, and it continues 3.0. Last like a 0.0.255.255, it is last of that series, and it is become again 0.1.0.0. It continues like that. It will fulfill up to 255.255.255. So this is a total range of IPv4 is 0.0.0 to 255.255.255 kind of stuff. Guys, understand up to here IPv4?
Yes, sir.
Yes, sir.
I will continue this part. Okay. Just I will tell small few points about IPv6 also. Of course, one or two additional comparisons are there next, but we'll see because we should not forget about IPv6, right? So IPv4 is 32-bit, IPv6 is 128-bit. In one last class also someone has asked me, sir, where is that 64-bit? They implemented IPv6 as a 128-bit only because it's a very big number. Okay, so maybe IPv5 maybe they implemented with 64, but as compared to IPv6, IPv6 is bigger. How much bigger it is? 2 to the power of 128 is 3.4 billions of IP addresses. Exactly right. 3.4 into 10 to the power of 38. 3.4 into 10 to the power of 38 IP addresses. It means every person will get at least like in a world population is very high, right? So each person personally they will get a one single or a double 2 3 IP addresses also, means which is big, very big, lot of IP addresses we are getting from IPv6, guys. But in a worldwide, including like people are dual mentality people. This I don't know, dual mentality or single mentality, what word that we don't know, guys. We never understand. We don't always don't put in a positive or negative way that people say India is like a very great and we are getting now. Earlier it is not there. Or maybe we'll compare other countries for all our failures. Not required. So use, we don't try, we use what is successfully used for. Like we are using a mobile phones, the smart mobile phones, normal mobile phones. Okay, but these are all already created like electrical cars. Electrical cars also built earlier in other countries, but they're successfully failed. Why you want get a failed version? Okay, difficult to implement. Lot of energy we are wasting. Okay, so that's why India will make sure about things. That's why we don't implement that much faster. Few things will implement. Okay, so do not worry. Still, 5G is not yet launched, right? Some countries they launch because still there are in a research in Indian. So our environment is our mind, right? So other communication should not be affect on other communications. Okay. So we want to secure. That is very important. Not this government, that government kind of stuff. Okay, guys. So IPv6 is globally 100% not using. Okay, so 1/8 percent, 1/8 or 1/16th, I didn't remember. I think 1/8 per part of IPv6 only released into the market. Next one is not all countries, including America, like a countries also not using IPv6 in the public communication. Still, there are also using IPv4 because of the world and big countries. Still, their routers, their public communications and all are configured for IPv4 only, not with the IPv6. Okay, but still there is a certain countries like Germany, Japan kind of countries, countrywide they are using IPv6. There is a conversion between IPv4 IPv6 part, so they may manage that one. In India also, in a private sector, some organizations implementing IPv6. Example, Geo using IPv6. IPv6 is more secure than IPv4. IPv6 is 128 bits, 2 to the power of 128. You will get a 3.4 billions of IP addresses. 3.4 into 10 to the power of 38. The IPv6 write in a hexadecimal format. Guys, hexadecimal. Anywhere I have put this table. Yeah, here it is. This is the table. See it is. This is the hexadecimal 0 to F. 0 to F. Normal decimal format 0 to 9 and single digit is finished 0 to 9. After 9 it is 1 0, means double digit. So the single digit is up to 9, but it is 0 to F. See the F in the sense of binary, it is 4 bits are there, 4 ones. And the next to F, next to is a 1 0. This is the 4 bits become 5 bits here. So it meaning is the maximum size of the binary for any of the single hexadecimal is 4 bits. Okay, is a 4 bits only maximum 4 bits we can use for representing a hexadecimal number. So one hexadecimal represents 4 maximum 4 binary bits. Maximum 4 binary bits. Right, one hexadecimal is represent 4 binary bits. So total bit is 128. So 128 by 4 means 32 hexadecimals. To write a IPv6, we need a 32 hexadecimals. 128 bits are bigger and 32 numbers 0 to F. Okay, any number it is, any decimal, any hexadecimal, right? So 32 hexadecimals we are using. In that one again, 4 hexadecimals for each 4 hexadecimals. Okay, so 4 hexadecimals we call it as a block, and each block is divided by colon. Each block is divided by colon. Okay, so 4 hexadecimal called 32, sorry, 4 hexadecimal numbers is grouping and become a block, and it is each block is divided by colon. It means there is a 8 blocks are there. Okay, this is the example of IPv6. So there is a 8 blocks. Each block contain 4 hexadecimals. So this is a about IPv6, and also you can see different ways to represent IPv6, different way of IP addresses also there. So IPv4, IPv6. While you are communicate in IP addresses schema, there is a loopback or a local host address. Guys, if you look at this screen, you can see there is a computers A, B, C, D, E. A computer IP address is 192.168.1.10 and B PC 1.102, 101, 102, 103, 123, 137. EPC is 137. I have written in the bottom. Okay. So every PC having an IP address. Every PC having an IP address. For A want to communicate it to B, like a ping command, ping 192.168.1.102, right? So A want to communicate it to B, so it use B's IP address. A want to communicate it to D, it use D's IP address. A want to communicate it to A only, A itself. A want to send a packet to A only. So it can use A's IP address, or there is a local host address. Guys, I have a laptop. My laptop having a computer name. My laptop has a computer name is there, right? You have laptop, your laptop having a computer name. Okay, your laptop having a computer name, but both laptops having a itself there is a name called a local host. My laptop is, for my laptop it is a local host. Okay, for example, I am there, like you are someone is want to speak to me, like want to address me, like hello Latif, hi Latif, like that, right? So address me with my name, but for myself, it myself, right? Yeah, it's me myself. It's me myself. So I am. This is like these are not names, right? It is myself. It is not a name, but it is the name for yourself only. So that is called a local host. and there is an IP address called 127.0.0.1. It is a self IP address, okay, which is not used to communicate to other PCs. It is for a self communication. It is for a self communication purpose. In the EPC, I installed a Oracle application. Example, I installed a Oracle application or some web application. From EPC only, I want to communicate. Okay, I want to communicate to EPC from EPC. So I open a command prompt. I'm trying to get to connected to my EPC inside only. Like this is my laptop. I want to communicate to my laptop myself only, self only, like ping 127.0.0.1. I'm pinging. So where is this address? That is also my PC only. Okay, that is also my PC. So every PC having a IP address to communicate to each other. Okay, but every PC having its self IP address is there. That is called a local host or loopback IP address is 127.0.0.1. It is a very important point, guys. Do not forget. And mostly like last 15-20 years also people are asking these questions. Okay, it's a standard question. Okay, what is a loopback address or a local host address? Is a 127.0.0.1. Every PC having that IP address. Okay, if your PC also having the same name, same IP address. Okay, what is the use of this address? It is used for self test. It is used for self test. Your TCP IP protocol working or not. The TCP IP protocol is working or not. So for that test purpose, we are using 127.0.0.1 and okay. And next part is self communication. For example, I have a server. For example, sir is asking like for example, I install an application like a Oracle database application in my laptop. Already I have installed. Okay, I'm not opening it. I installed already Oracle 21C database application in my laptop. From my laptop, I want to access. From my laptop only, I have to access. So whether I have connected to network or not, no problem. I am using my local host address. So name like a local host or a 127.0.0.1. I use this address to communicate to my application because it's network based application it is. Okay. Direct some thing like a application directly we can't open that application. So there is no double click and open kind of stuff. So you have to communicate through the network based protocol. So like SQL plus kind of commands or a SQL developer based applications that using that I will connect to my application. For example, you see EPC Oracle database is there. From EPC only I am using 127.0.0.1 to connect to the Oracle database server because both are in a same PC. Same from APC I want to access EPC Oracle database. So where is the Oracle database application? In EPC. I want to access from APC. Which IP address I have to use? EPC's original IP 192.168.1.37 I use to connect that application because 127.0.0.1 is belongs to for internal communication means PC to that PC only, PC to that PC only, self communication. But if you are communicating from one PC to another PC, use that their main network IP address only, their uniquely identified address only. So in IPv6, this same localhost address is colon colon 1. Okay, colon colon 1. So here it is also where a lot of things are there. For example, Jenkins, when I install a Jenkins in my PC, so I want to access the Jenkins using web browser. Okay, so it's having built-in web server. It is there is a built-in web server in the Jenkins application, so you can access with a web browser. So my Jenkins in my PC, I'm accessing from my PC. So I will use 127.0.0.1 or a local host address kind of stuff. Next is 0.0.0. This is the unknown IP address, or it is a reserved IP address used in a certain services. For example, default routings, DHCP DORA process, okay, or to saying like unknown IP address kind of stuff, okay. We are using in IPv4 0.0.0.0. In IPv6, just colon colon only. In IPv4, we have a unicast addresses, unicasting, multicasting, broadcasting is there. In a IPv6, we have unicast, multicast, and anycast. In IPv4, we have a classes, class A, class B, class C. IP addresses are divided into class A, class B, class C, and class D, class E. In a IPv6, we have a different type of classes here. It is so IPv6 don't have any classes, but it is divided like this. Link local IP address. What is this link local IP address? Every device which is enabled with the IPv6 protocol. You have an adapter, okay, you have a adapter, okay, right, IPv4 IPv6 IP addresses we can put it, because if IPv6 is um, built-in protocol, it is IPv4 is also a protocol, okay. So if IPv6 protocol is there, so automatically the device uh, creates its own IP address. Like APIPA means if you don't get an IP address from DHCP server, PC is assign its own IP address from APIPA range. In IPv6 also, in IPv6, every device, every NIC, every device, the system automatically generates an IP address for each and every device which is valid within the LAN network. We cannot communicate in a WAN network, but this IP is valid in a LAN network. It means if we are using IPv6, we don't require DHCP server. You no need to learn how to assign IP address manually also. It means you have a 10 computers or 20 computers connected in the network. You are not assigning any IP address manually or through DHCP. Still, in the LAN, we can able to communicate. How? Because of this link local IP address. Every PC having a link local IP address if IPv6 protocol is enabled. You can easily identify link local IP address with a FE80 colon colon. After FE80 colon colon, there is some number will be there. It is a private IP address, local IP address. This IP address is generated based on your system MAC address only. It is generated based on your adapter MAC address only. Okay, it is a link local IP address. To communicate outside, to communicate in a public, so we have another scheme, that is a global unicast type of address is there. So that is a public IP address. Link local is private IP, means for internal communication, automatically generated by the system using a MAC address is a link local. Not only these two guys, there is a in IPv6 we have a private IP addresses range is there. Public means global unicast is a public, private IP address, multicast address, anycast addressing is also there. But I have given only two names. So this is about your IPv4 and IPv6, and this IPv6, sorry, this IPv4, I already told it is divided based on the classes. Okay, so we have a total IP addresses. If you look at this total IPv4 addresses from 0.0.0.0 to 255.255.255. Okay, so in this total bunch of IP addresses are divided into five classes. Based on the first octet of the IP address. Based on the first octet of the IP address. You can see these are the different IP addresses, but out of these IP addresses we'll always see their first octet. Okay, so based on the first octet we can identify which class of IP address it is. Okay, so the class A, class B, class C, class D, class E. Class A, the range is 0 to 127, 1 to 126. Why bracket 1 to 126? Because of the 0.0.0.0 is a reserved IP used for a certain places like a default routing and DHCP DORA processing we are using. And also we don't use 0 series. You have to start using from 1.0.0.0 series. Next one, already we discussed 127.0.0.1 is a reserved IP for a local host or a loopback address. Of course, 127 series also we are not using. So that's why in some textbooks or some internet web kind of stuff, it shows 1 to 126. But original range is 0 to 127. Compulsory, you should know the reason why it is 1 to 126. Okay, so class A is 0 to 127, class B 128 to 191, class C is 192 to 223, class D is 224 to 239, class E 240 to 255. Class E is a R&D, means we don't use this range 240 to 255 range. We don't use for our general communications. Class D is a multicast address. Multicast addressing means to communicate to the group of PCs. Within the group of PCs, they want to communicate each other. Okay, just all are like I send a message to the group. It is like a multicast. For example, we discuss about routing protocols, right? Routing protocol, RIP version 2, EIGRP. I have a 10 routers configured with the EIGRP. These 10 routers will communicate, these 10 routers exchange information about routing information using a multicast addresses. Like 224.0.0.9 or something, 5, 9 is there, 10 is also there. So it depends upon protocol. I didn't remember exactly to whom to do. Lot of years completed. Okay. So what is the multicast addressing? to communicate group of computers for a certain process or based on a protocol. For example, boot P protocol. I want to install a operating system in a 10 computers through network. Each computer having an IP address, regular unicast IP address is there. And but when I am deploying, right, I have to give my booting information, or maybe I have to load operating system files. So to load it for 10 at a time, so then I use a multicast address automatically. Guys, we are all using a unicast address to communicate one to one. Right? So we'll ping from A to B, or B to C, or C to D, D to A to C, C to B. Okay? So we'll communicate one to another one, not one to many. Right? So we need a unicast address is important. Of course, only unicast address we can assign to the adapters. You want to give an IP address, you have to give IP address in either class A or class B or class C. You have an organization, you want to implement an IP network, you can pick up class A, class B, class C only. You cannot assign class D or class E. Why cannot? Class D is a multicast address used by certain protocols, multicasting related protocols uses directly. So you need to tell a class D to use this IP address. Okay, so something like that. Okay, class A, class B, class C. Out of that one, 0 series, 127 series, we are not using. Of course, 169.254 series also we are not using. So this is the first one is, yeah, what I will do it, I will remove this. You can add more, no problem. See here it is, guys, it's a 120. See the first octet and see the range 120, right, is a class A. 151, which class it is? 151. So there is 200 is also there. Don't mind about it. Always check the first octet. 197, class C. 197, class C. Anybody? 224?
Three, sir.
No one is speaking. Yeah, very good. This is which class it is?
B.
Very good.
B.
Class B. Very good. Okay. So we are, so 192 is there, 240 is there, 10 is also there. But we have to see the first octet only. 170. 170 is belongs to class B. Okay. So that is a important. You can take any IP address. I can identify which class it is. It is 120, 192. It is class C. So each class, like mainly we are using a class A, class B, class C, because class A, class B, class C are unicast address. Class A, class B, class C are a unicast addresses. Okay, so these addresses having a subnet mask, okay, and network and host version part is also there. So class A subnet mask is 255.0.0.0 as a default subnet mask. Class B 255.255.0.0 Class C is 255, 255, 255.0. 3 classes. Okay. Next, yeah, there is a big story is there. What is this network and host portions? So guys, what you will do? Take a break. We will continue from here. What is classes? What is network portion, host portions? Okay. And if you take two IP addresses, whether they will communicate each other or not. So we'll see it. I will jump. I will explain what is the use of this subnet mask. What is the meaning of subnet mask? What is some subnetting? I will tell that's it. Okay. What is slash notation? I will tell. Then we'll also see private IP address, public IP address, NAT, PAT communications. Apipa is there still. Apipa already I told, I think so. So we'll see these things. Okay. So take a break, guys. Come back by 12:10, 15 minutes break. You tell me.
What is
What is
Dora?
DORA?
Yes, sir.
Discover, offer, request, acknowledgement. This is my DHCP server. This is my DHCP server. This is my client. Client means in this PC and the network settings, I put a like this: obtain IP address automatically. Okay, I put obtain IP address automatically. It means it will get IP address from DHCP server. But originally what happened is the client PC, right? Initially, the client is started like you switch on the client. Client don't have any IP address is configured. What it will do? First of all, it try to reach where is the DHCP server. Okay, it will try to send this broadcast message to multiple places. Okay, so where like a multiple pieces, whether it is DHCP server or not, does not mind. So it is keep sending to everyone. So this is a DHCP server, but this PC is sending to multiple people. Okay, to those who are connected, like there is a 10 computers are connected, the client will send the message to the 10 computers. This is how DHCP works. Okay, 10 computers. Are you DHCP server? If you don't know who is the particular person, okay. For example, you went to an office, you have to meet the assistant manager. So you see there is an office boy, you can identify an office boy because of their dress and all. You may be seen the front desk. Okay, so you have to search and find out. So what you will do? So maybe you can recognize when some name board and all. But in the network, so we don't have any IP address. We don't know who is the DHCP server and all. Everybody's look like same. Everybody's connected. Okay, everybody's look like a same only. So we don't know who is this person. Everybody wear a suit. Who is the assistant manager? We don't know. What you will do? You'll ask, right? Sir, are you assistant manager? Where did I find like this, right? So the client send a packet called a discovery packet. The packet is discover packet. Okay, client sent to everyone in the network. Everyone in the network. So it will ask, are you DHCP server? Are you DHCP server? RU DHCP server. So other PCs will drop the packet. They didn't respond anything. They will drop the packet and DHCP server will pick up the packet. Okay. It accepts the packet. Yes, I am the DHCP server, and do you want IP address? Like I'm this server is offering exactly say like this. It means this is the server, this is client. Okay, the client try to send a discovery, server receives, and server send a offer. Server is giving offer to the client. Do you want this particular IP address? I have this IP address. Do you want it? Just giving a offer, and immediately the client will send a request. Yes, I want a IP address. Then server will give an acknowledgement. Yes, take this IP address, give this lease uptime, lease duration. Okay, like a lease uptime, lease duration part like a lease expiry, DHCP server address, DNS server address, default gateway, subnet mask, and IP address. So your client will get finally IP is configured. So initially we don't have any IP address. That time I use my source IP as 0.0.0.0 for broadcasting discovery packet. I will ask my PCs, those who are connected in the network, are you DHCP server, are you DHCP server, are you DHCP server, like that. Whenever the server, when we have a DHCP server in the network, so DHCP server will respond, yes, I am the DHCP server. Do you want an IP address? The client say, yes, I want an IP address, and please give me the IP address details. Please configure my network. So by sending request, and the server send acknowledgement. So then client configured with the IP address. So discover, offer, request, acknowledgement is called a DORA process. DHCP IP address process, like how DHCP server will give IP address, the process we call it as a DORA process, because the first word D means discover, O means offer, R means request, A means acknowledgement. Okay,
Okay, sir. Thank you, sir.
got it. Very good.
Yes, sir.